In this video, we will learn how to use the circuit simulator on filestat.com. When you first load the page, you will see this circuit. This is simply the default circuit that you will see in the beginning. We notice that it has a resistor, an inductor, and a capacitor, as well as a switch, a battery, and resistor. This is an RLC circuit. But this is not something we need right now. So let's stop this simulation. You can find the stop button over here. Press stop. And now let's disassemble it. I don't need the inductor, so I click on it and press the delete button. And let's remove a few other components as well. All right. You can see the colors on the capacitor not quite the same. That's because there's still some charge left over from the previous simulation. So I press the reset button, and now it's all the same color. What else do I need? Well, that depends on what circuit I want to build. Let's say I want to build a slightly complicated RC circuit. Most of the controls I need are here in the upper left. Mostly I'll be using draw. So resistors certainly are one of the most common components, so I'll click on that. And now I click and drag. And I have a 1 kilo ohm resistor. That's 1000 ohms. Of course, though, it's not connected right now. So I need some wires. Again, I go to draw and I click add wire. Click and drag. There's a connection there and a connection here. Of course, this alone is not enough. I need a battery and a switch. Again, we go to draw. We see wire, we see resistor, and then we see a list of various possibilities. Passive components include capacitors, inductors, switches, SPDT switches, we'll see those in a moment, and a variety of other things, including transformers. So that's where we can get capacitors and switches. We can get inputs and sources. Here we have a voltage source with 2 terminals, which is a battery, which is what we want. Click and drag, and there's a battery. I'll drag it all the way so it makes a connection, and that's ready. I need a switch, so I go back to passive components, click on switch, and draw that there. The switch is right now closed, but if I click on it, it will open. Now, I still need to finish up the connections, so I go back and ask for a wire, but now I want to point out something. Supposing I draw my wire like this. Notice, however, this little red dot. And also notice that it says here bad connection. So the way the simulator is set up, you have to go from the end of the wire. You can't make a connection randomly in the middle. So this is a bad connection, which is why it's showing up in red. It's not actually connected here. And the proof is if I close the switch and press run, we don't have a flowing current. Right? We will talk about what these yellow particles are, but right now the green indicates a high voltage and the gray indicates a low voltage. So we can see all of this has been put up at a high voltage, but there's no connection here, so there's nothing flowing. I press stop, I press reset. All right. And I need to make the connection correctly, so I delete this wire and add a few more. Click on the switch to leave it open, and now we are ready. Let's see what happens when I press run stop and then close the switch. First press run stop. We see that now all of this is at high potential. until the switch. And then on the other end, it's at low potential. Right now, there's no current flowing. And I click on the switch to make it close. And yes, we see now that there's current flowing. There was current flowing here until it stopped. However, there is still a viable loop through this resistor. And so the current continues to flow here. So these yellow dots each represent a certain amount of charge. And so you can see that they are flowing around. We could change the animation slightly by moving the current speed, but now it's moving too fast. So let's slow it down. It's somewhat sensitive in this case, so we'll leave it around there. Now, how can we play around with the system? Well, let's stop it. If I press the switch now, it opens. I can press run stop again, and we see now that the capacitor is discharging somewhat slowly. Press stop. And then I press reset. Supposing I want to experiment with a smaller resistance instead of 1000 ohms. I right-click on the resistor and I see edit. Right now it's set at 1K. Let's turn that down to 200. Click apply, okay. All right, it's now a 200 ohm resistor. Let's say I don't want 15 microfarads. Again, click edit. 15U, here U standing for micro. Let's say I want something smaller. I go for 10 nanofarads. Okay, that has been changed. If I now run the simulation and then close the switch, we see the current is flowing at a faster pace. You might say, why is there no current flowing here? Because it's a smaller capacitor, it got charged very quickly. Let's check that. Go here, reset, and now edit the capacitance. Let's make it fairly large. Let's make it 1 farad. All right. If I press run stop, we can see there is still current flowing here because it's still in the process of charging up. As time passes, it gets slower and slower. I can open the switch and close it. All right. So that shows us how to move circuit elements around. But how do we get this graph? And how can we play around with it? I press stop. And I am going to remove the scope. All right, so I need some measuring instruments. I again go to draw, and I see outputs and labels. I will want a voltmeter, and I want it across the 1 farad capacitor. So I click and drag that there. And let's say that I also want an ammeter. Well, voltmeters are placed in parallel and ammeters are placed in series. So I click on this wire, I delete it, I go to draw, I go to outputs and labels, I say add ammeter, and I put that in there. Need a few more wires. So let me add those, add those. All right. Supposing I want to adjust the voltage of the battery, right click on that, edit. Right now it's 5 volts. Let's step it up to 12. All right. Now we're ready. press reset, and then I press run stop. And now I close the switch. So we can see that there are readings taking place, but where's the graph? I go to scopes, I say, I right click on the voltmeter and say view in scope. Now I right click on, right click on the ammeter and say view in scope for that. And now I have the voltmeter reading and the ammeter reading. Now you might notice that there is both a green line and a yellow line here. So what is that about? Well, actually one of them is the voltage and one of them is the current. The yellow one is the current corresponding with the yellow dots moving around, and the green one is the voltage. If I right click on this scope and go to properties, you can see right now both voltage and current are ticked off. I can uncheck voltage and leave it as just current, and we see that. We can see that the voltage is steadily getting more and more negative, and the current is holding steady. Or is it? If we look carefully, we see the current is actually decreasing. How can we see that more evidently? Well, we can increase the simulation speed. The voltage is clearly increasing in magnitude. It's becoming more negative. And the current is clearly decreasing. It's gone down to 116, 115, and so on. Press stop. All right. Let's say we want to put an AC signal instead of using a DC battery. I click and remove the battery, and then go back to draw, inputs and sources, and I see I have an AC voltage source. Click and drag. And this is the symbol for an AC source. It's a circle with a sine wave inside it. If I right click and hit edit, I see that this is an AC waveform, which is basically sinusoidal. It has a frequency of 40 Hertz and a maximum voltage of 5 volts. That means it goes between +5 and -5 volts. I right click on the voltmeter and say view in scope. Right click on the ammeter, view in scope. And let's see what happens now if I let this circuit run. Well, first I reset it and then I say run. So we see the current is flowing, and now it's slowing down. And now reversing. This is the nature of an AC signal. It goes positive and then negative. And so the current flows first one way and then the other. We can see that happening in the ammeter. The current was initially positive, but now it is negative because it is going against. Let's say we speed up this simulation a little bit. We see that the current follows a nice sinusoidal pattern. The voltage across the capacitor is very interesting. We see that there is some voltage, but it's wiggling up and down. So there is some steady amount of charge in this case, but there is a sinusoidal pattern imposed on top of that. What if I don't want to use sinusoidal waves? I can edit it and instead choose a square wave. we can see that both the current and the voltage have changed. And I can view the input voltage directly. I can change from a square wave to sawtooth. And triangle. And stop. Finally, we look at the other type of switch, which is the SPDT, which stands for single pole double throw. Here we see that the switch, if I flip it, goes from one possibility to another. How do we use this? Well, let me redesign the circuit a little. I want to move this around, so I click on Draw, Drag select, and move that into position. Now we're ready. Let's see what will happen when I press run stop. I flip the switch. And right now we see that there is a complete loop, including the battery. I press run stop, and current is flowing as expected. Notice there's no current flowing through the 200 ohm because it's not part of a complete loop. What happens if I flip the switch? Well, before we do that, let's increase the simulation speed a little bit. It's going to take quite a while this way for the charge to build up on the capacitor because it's such a large capacitance. So let's decrease that. Let's make that 1 millifarad. There we go. We see the familiar curves. And now I flip the switch. And we see that the capacitor is starting to discharge. And again, we see familiar exponential type curves. All right, have fun playing around with the circuit simulator. We'll be using it in a few different labs.